So this is our lesson today. In this lesson, we learned about the exponential function. And as we said, as I told you before, that the exponential function, there's a difference between the expression and the function. We said if we have 2 raised, x raised to 2, 3 raised to 4, like a, b raised to the power -7, like this, we are calling this an exponential expression. Today, we are talking about exponential function. Any function, it must has this formula, y equal f of x. So if y equal 2 raised to the power x, like 5 raised to x, 7 raised to x, where an power or where an x exponents changed, we called it an exponential function. And also we said that in this lesson, we learned about 2 types, or can say 2 types of function. We are talking about linear function. We are talking about exponential function, and also quadratic function. I will give you now 3 examples for them. For the linear or for the quadratic. For the quadratic, you have a variable x where it is changed, raised to the power 2. The 2 here is constant. Every time we have a variable raised to 2. That's named quadratic function, x squared. The exponential, no. We have base 2, but it is raised to the power x, where x here is changed. But for the linear function, it's like 2 times x. This is, we called it linear function. Because x is, if it's like x of 1, when x is 1, y is 2. When x is 2, y is 4. We called it linear function because the difference between the x values and the y values are constant. Because of that, we say it is linear function. This is now the difference between them. So the exponential function is y equal a times b raised to x. This one here, as you say, it could be like 3 times 2 raised to x, or 4 lines times 7 raised to x. These are an examples of exponential function. That's we have a variable or base 2 raised to variable x multiplied by 3. Now, as you look here, as these are the graphing of the exponential graph of 2 to the power x, how it will be. Later on, I will tell you how to graph it, but just here, look at it. Y equal 2 raised to x, it will be this one, the red one here, as you see. To negative 2 to the power x, it will be, as you see here. Half raised to x, it will be like this, and negative half raised to x at the graph, it will be as you see here. Now, before that, let's now, I told you that if you have an x squared, what we call this function? Quadratic function.
Teacher.
Yes?
Teacher, when we're gonna solve the questions?
Excuse me, sorry?
When we will start doing the questions?
What did you mean? Did you mean that you didn't see what I wrote?
No, when we will do the questions to answer.
Wait, just I was describing the lesson. So, now, so if you have y equal x squared, because of that, we say that it is a quadratic function. If we have now y equal 2 raised to x, we say it is an exponential function. So, and 2x, we say it's linear. Deal? This is for now the 3 types of functions. Now, he told you that if I give you this table, and as you know that for each function, if we have value of x, you have y, which is f of x. x1, x2, x3, and so on. The values of x. As an example, if you have here a table and you use a function, and after you evaluate with the function, you find that the values like 1, 2, 3, 4. These are the value of x. And if you go to y, if you find it like 2, 4, 6, time, and 8. This is a table. And another table you have here, any function. If I need to write any function, I need x and y. If you have now, these are the values of x, and the values of y is like this. Okay, look here, as you see, we have these 2 tables. For these 2 tables now, we have x and y, values of x and values of y. Now, what I have to do, I want to guess now, is the first table is linear function? In this lesson now, on this period today, we are learning how can we differentiate between exponential and linear function. Exponential is 2 raised to x, and linear, it is 2 multiplied by x. Okay?
Okay, teacher.
Then, so here as you see, the first step, suppose all the x values in the table have a common difference. As you see here, what's the meaning of the common difference? Look at 2 minus 1 equal 1. 3 minus 2, 1. 4 minus 3 is also 1. So we have a difference. Isn't this difference is common? Yes. So in the x values, we have a common difference. Now, go to the y values. 2. Let's see now the difference between them. 4 minus 2 is what? 2. 6 minus 4 is 2. 8 minus 6 is also 2. So the difference here is 2. So did we have a common difference?
Yes.
Yes. Since now we have in x a common difference and in y a common difference, if we see a common difference in x values and y values, so this table is a linear function. So I can say that now that this table now is a linear function with y equal 2x. Why? Because we have a common difference in x values and a common difference in y values. Now let's go to the second table now. The first step, is the first table is clear?
Yes, Miss.
Yes.
Okay, but girls, please, wait 1 minute, please. Yes. لا هي نفسها هي لأنه نفس الأصوات اللي كانت تطلع تصفيق من نفس البنت. بس هي كنا كانت تدخل إلى مرات مثلا كانت تدخل من أكونت ثاني، يا أما أن تدخل من أسماء ثانية، تستغل أسماء البنات. داخل مرة باسم نور راح أقول البنات نفس نور، هم على تخميناتهم من تشابه الأصوات. هي كلها على لا على 10 لسه هي احنا حسبناها بين 9:30 تقريبا، بين 9:30 و 9:30 يعني انهم كله دخلوا مع بعض اليوم. وحتى اخذت حضور الغياب حتى اتاكد بالموضوع، لما نزلت عليها ما عرفت عليها. الساعة المفروض انا عندي الفيديو مسجل، حتى اخذت حضور الغياب اليوم بالعمل كنت مسجل الفيديو تسجيل الاول، حتى لما نزلت عليها ما عرفت على شيء واضح يعني ما كنت عارفة هلا مسألة انت بامكانك على انظمة تدخلي على التيمز تبعي هلا وانا فاتحة وشوفي في اول جزء من التسجيل. انا نزلته لاني بلشت تسجيل عشان الحصة، فالجزء الاولاني بس شوفوا فيه اسمه صوت البنت ويبتحكي ويطلع ازعاج. وانت دخلت برضه حتى لو عليها على اسم دينا كيف ما ردت علي وردت حتى هيك واضح ما حبت تعبر لي. لا هي انا طلعتها من على 10 إلى ربع أنا. طيب هلا يلا بس I'm sorry girls.
Teacher?
Yes.
Farah go out from the class because her mobile is not working good, so she will return, okay?
Okay.
Mama, it's Ma, it is blue.
Where's Farah? Hello. Okay.
Mama, so high, Anna.
Okay.
So high, Anna.
Sorry girls. So for the first table, is it clear?
Teacher, sorry for getting out because my telephone shut down and now I cannot see anything. They're telling me that when the meeting starts, they will inform you to let me in.
Okay. Okay, that's okay.
Now,
So girls, okay Farah. Now until now girls, as you see here, is the first table clear?
yes, miss.
Yes, yes.
Okay. So by now, as you see here, the first table, there has a common difference. We have a common difference also in the y values. So because of that, it's a linear function. Now let's go now to the second table here. Here now, 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is also 1. So did we have a common difference in the y values? In the x values, sorry? Yes. These are in the x values. Now let's go to find the y values. 2 minus 4, 4 minus 2 is 2. 8 minus 4 is 2. Is it 4? Is it common? Is it the same?
yes.
No, look here. 4 minus 2 is 2. 8 minus 4 is 4. 16 minus 8 is 8. Is it the same? No. In the previous table, we have a common difference, which are 2. But here, we don't have a common difference.
Teacher, in which problem you are?
This is not a problem. This is before we start the problems.
Teacher, screen is black. Can I rejoin?
Okay, Farah. Okay, you can. So, as we see here, if we have two tables, okay, the first step now, I will check the difference between them. 1, 1, 2, 2, 3, 3, 4, 4. So the first step, look at the x values. Here, 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. So the common, did we have a common difference? Yes, it's equal to 1. So we have. Look at now the y values. Here we have a y values. 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. For the y values, did we have a common difference? Difference, it means that if we subtract, or the difference between two values are the same. So they are common difference. So yes, we have, which is equal to 1. So because of that, we will name it as linear function. Now, let's now, if we have 1, 2, 3, 4, and the values 2, 4, 8, and 16. Look at now the x values. 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is also 1. So did we have a common difference? Yes, we have a common difference. Now what about now the y values? 2 minus 4, or sorry, 4 minus 2 is 2. 8 minus 4 is 4. 16 minus 8 is 8. Is it common? Is it the same? The difference between each two terms, is it the same? No. Let's try now the common ratio. Sorry. Let's try now the ratio. What's the meaning of the ratio? Ratio like 4 divided by 2. Here, I'm talking here. 4 divided by 2 equal what? Equal 2. Then, yes?
It doesn't appear the right side.
Now?
Nothing. The last thing that appeared, common difference equal 1, correct.
Other girls, is the screen appear for you?
Yes, Miss, it's clear.
Yes. Yes, it's clear.
I think there's a problem with your mobile today.
Teacher, I have a question.
Yes.
Why you remove the 72?
Where's 72?
It was the second y. It was 2, 4, 8, 16, 72.
Ah, 64 you mean, 32 you mean. Okay, I'm sorry. I forgot to write it. Okay, thanks for that.
32.
Yes, okay. So here,
Welcome.
just now to find the ratio between the second and the first term. 4 divided by 2 is 2. Now, 8 divided by 4 is what? Is also 2. 16 divided by 8, 2. 32 divided by 16 is also 2. So, did we have here a common ratio?
Yes.
Yes. So, because now we have a common ratio, we call this function an exponential function. So, these are the difference between the exponential and the linear function. The linear, that there we have a common difference in the x values and the y values. Or we can say that at the y values. If the y values has a common difference, so it is a linear function. But if the y values has a common ratio, it is an exponential function. Let's now do problem number 1.
Teacher,
Yes.
Teacher,
Yes.
are you gonna take the break?
No, because we lost 15 minutes. طب see, but I want to solve this problem and you can go, okay?
Okay.
Teacher, the exponential function. It means that all the y values have common difference.
It's the exponential. No, it has a common ratio. But the linear, it has a common difference.
Common ratio, teacher. What are the ratio for the last example you give?
The ratio was 2.
Okay.
Okay. Now here, identifying linear and exponential function. In this one here, we have to look at this table. From this table, I want now to see if they are linear or exponential. Look here now. We have 0, 1, 2, 3. Here we have -1, -3, -9, -27. The first step, I want now to check here if they have difference, same difference. Yes. Okay, but this common difference doesn't matter. The one who told me that this is a linear or an exponential, the y values. The y values who can differentiate me if these values are a linear or exponential. Look at these values. Now let's check. Does it have a common difference or common ratio?
Common ratio.
Common ratio, is it right? Common ratio, is it right?
Yes.
Yes.
Tell how you know
Yes.
that this is different
Okay,
ratio.
look at, how can I know? Let's now find the difference between each two terms. -3 minus -1. Is it -2? -9 minus -3, it is -6. -27 minus 9 minus -9, it is -18. Is they are common? Is they are the same? Sorry, the
No.
difference are the same? No.
No.
So they are not, we don't have a common difference. Let's see now if we have now a common ratio. By how? By find the ratio between each two terms. -3 over -1 is equal to 3. -9 over -3 is equal to what?
-3.
-27 over -9 is equal to 3.
3.
Is it the same? Yes. So because we have a common, so because we have a common ratio, so we can say that it is an exponential function. Look at number 2 now. Y equal 3x. Okay, look at the variable x here. Y is equal to 3x. Is the variable x here is coming like a power? Is it a power?
No.
Yes. No, it's not a power. It's multiplied by 2. But it's not as a power. It's not like this. That's mean it's a power. A power like 3 raised to x. This is a power. But here it's not a power. Because it's not a power or it's not an exponent, I can say it is a linear function.
Oh, teacher, I didn't understand how we will find the exponential function.
Here from this exercise?
I'm not from the previous problem 1, number 8.
This one.
Yes.
How can we know it is linear or exponential?
Yes, or
Okay.
it must be the x values, either plus or subtracting or
Don't
adding.
don't look at the x values. So look at the y values. For the y values, you have to check two things. If they have common difference or if they have common ratio. Did you know what's the meaning of common difference? How can I find it?
Yes.
A common ratio.
Common ratio,
Ratio, what's the meaning of ratio? Ratio, it's mean that the second term divide by the first term. These are the ratio.
Okay.
Okay? As you see here now, look at the y values. Did we have a common ratio?
Teacher, what is the word written under common ratio?
What? Can you repeat?
What is the word written under common ratio?
What is what?
The word that is written under common ratio.
Here? Second term over first term. Did you mean here?
No. Down. The last thing.
Exponent.
The word
This
written
one?
up. Yes.
Exponential function.
Okay.
Okay. So by now.
Please, teacher,
Yes, Farah. I will go to the y values. I will try to find if they have a common difference or common ratio. Common ratio, that's mean I will divide each term on the previous term.
Okay.
After I dividing them, if we have all the ratios are the same, so we name it as a common ratio. And I will go back to my rule. Here, my rule told me that if we have a common ratio, the table represents an exponential function. So this function are exponential.
But teacher, here, -9 divided by 2.
Why by 2? -9 divided by -3. No, don't divide y into x. Divide the third y into the second y, the third term into the second term.
Yani means, teacher, the second term is -3.
Yes,
and
the third term is -9. Divide -9 into -3.
Equal 3.
Equal 3, yes. So we have a common ratio.
Okay.
So this common ratio, it's mean an exponential function. In this one here, as I told you in the beginning of the lesson, if you have 3 to the power x and the variable x here is an exponent, because here x is an exponent, so I name it with an exponential function.
And
but
y
if you have 3 times x and x here is not an exponent, it's not an exponent, so I will say it is linear function. Is it clear now?
Yes, and this equilibrium, it will be x to the power of any number.
This is a quadratic, yes. It's a quadratic. We are not talking about it in this lesson, inshallah, in the next chapters, but just here to differentiate between them, that it must be 2 to the power x, not x to the power 2. Okay, girls, I'm sorry for taking 7 minutes from your break. I'm sorry for what the Dina make a noise. Thank you for listening. Have a nice day. I will see you tomorrow, inshallah.
Teacher, thank you for everything. Bye, teacher.
Thank you so much.
Teacher.
I love you. Bye bye.
Me too. Bye.
Bye, teacher. Thank you.
Bye. Bye bye.